This is a likely disposal site for the world's deadliest rubbish, nuclear waste. The high-security lab in eastern France is run by ANDRA, a government agency tasked with finding ways to stock the toxic material so it will be safe for millions of years. We're given a guided tour around the Underground Labyrinth by Alan. He's ANDRA's technical director. The project has been given a new impetus by an EU directive requiring all member states to clarify their strategies on dealing with nuclear waste. Leading the way so far are France, Sweden and Finland.
This lift will take us down to a depth of 500 meters. Today down there, some 50 experiments are underway. Some have been up and running and giving information for 7 years. The objective is to have a complete knowledge of the future stockage areas. We're also doing heat tests, because some containers will be hot, and we're checking that heat transmitted to the clay will not modify its characteristics.
Across Europe, several stockage methods are being researched. France favours entombing its 80,000 cubic metres of radioactive waste in a thick layer of clay that hasn't changed for 160 million years. But how will the Underground Labyrinth be sealed?
The main idea is to plug the galleries with clay, because clay has swelling properties. If you hydrate it a little, it will create pressure and push back the walls and close up, as much as possible, the micro fissures that occur on the periphery through the decompression of rock that had been in place for millions of years and all of a sudden is released. So it's a normal reaction.
But overhead all is not so quiet. In the hamlet of Spurred, protesters are mobilising for action. Francois doesn't believe the waste can be kept safe through future millennia as it's claimed. He's making his case loud and clear.
We say it's a lie, and they themselves know it's a lie. I've talked to miners. The moment you alter the structure of the rock, it creates areas of weakness, and from that moment, things move. We must never forget that the Earth is alive. We know that there are existing faults. How can a scientist of integrity claim the water will never filter through? It's just a scientific lie. It's a sham.
The site operator rejects these fears, saying the situation will be constantly checked. The project is truly vast, involving more than 100 kilometres of tunnels. So far, €1 billion has been spent on the project. The operator puts the final cost at 16 billion, but France's Court of Auditors and a parliamentary commission warn that it could be twice that amount. Opponents want the waste stored close to the surface to be more manageable. The site's technical director brands that proposition irresponsible.
Why deep in the ground? Because it's not reasonable to have this material long-term close to the surface, because we're not sure how to monitor or control it securely.
Another country, another solution. In the vast tracts of forest in Finland, they take a different approach, bury the waste in the bedrock. An explanation from the country's Energy and Economy Ministry.
Our bedrock is the oldest and most solid granite formation on the globe. It has remained stable at least for the last 2,500 millions of years. And there are quite nice chances so that it will stay stable for millions of years.
The Finnish project is centred at a nuclear power station on a remote peninsula. The site is cooled by seawater. Here we meet geologist Jussi. For the past 10 years, he's monitored the granite bedrock of the peninsula for faults and fractures. Is there any risk that seawater could seep in?
Most of the fault zones that we have do not actually intersect and come into the sea. Another thing is that the fault zones that we know that actually are under the sea, there's not enough hydraulic gradient to push the waters inside.
Our crew is allowed into the site for a closer look. Until the 90s, Finland exported its nuclear waste to Russia. But now there's a legal ban on sending it across borders. The country wants to manage its own waste and become energy independent. But deep below, we can see water has already entered the facility.
Well, and there is water, actually.
Yes.
So it's a problem, isn't it?
No, it's not a problem. When we put inside the canister with the nuclear waste, around that and between the host rock we have bentonite buffer. Now, if we have a high amount of inflow, that will be a problem because the bentonite buffer can actually erode away.
About 1/5 of the planned waste cavities that have been built at a cost of around €3 billion can't be used because of water risks. And there are fault lines in the bedrock in the area. So how safe would the nuclear waste canisters be?
You do have pathways to the surface, but in the case that the barrier system would fail, then we have the host rock and it has a quite high retention capability, meaning that the radionuclide, it would take for a very long time, and now we're speaking of tens to hundreds of thousands of years to reach the surface.
One part of the cave system already serves as a depository for low and medium radioactive waste. It's buried in 33-metre deep silos. If it gets parliamentary approval, the stocking of high radioactive waste is planned to begin in 2022. A century from now, the caves will be sealed, but will they remain safe in a future ice age?
Well, we know from northern part of Finland and Sweden that we have these so-called post-glacial faults, meaning that when you remove the ice cap, the glacier, you can actually have earthquakes after that. And the scenario is that we could have similar earthquakes here in Olkiluoto as well.
The radioactive waste will be packed into copper canisters. The valuable metal becomes buried treasure once again.
In each of these canisters we have around 7 tons of copper. And then we have 5,000 of these canisters, so that's quite an amount of copper. But that's one of the key aspects, how to prevent future populations to intrude in these repositories.
Back in France, the protesters say their campaign is for distant future generations.
There's a problem of memory loss. If our descendants come across this site, how can we keep alive the knowledge of it for such a long time, across thousands, even millions of years? It's essential that we do, so that it remains untouched.
The nuclear age may be long gone by then. In France and elsewhere, it's being scaled back over time as an energy source. At the same time, the rapidly increasing use of renewables is taking Europe in another direction, hastening the demise of conventional energy, carbon and nuclear.